Okay, so let's go over the midterm. First question, as promised, a tank question. And it says here that the water is flowing in, the salt water is flowing in at 4 liters per minute and out at 3 liters per minute. So the volume is not constant. The volume, in fact, goes up 1 liter every minute. Starts at a third full 30 liters. So the volume is equal to 10 plus T, right? At the beginning it's 10, then a minute later you get 4 liters in and 3 liters out, so now it's up 1, 11. So the volume is not constant. We have our y prime equals in minus out. 4 liters per minute coming in, 2 grams per liter, that's 8 grams per minute coming in. The out is going to be y kilograms divided by liters. The liters changes the volume, so that's kilograms per liter times liters per minute. There's my differential equation. It's first order linear, it's a y prime plus py equals q. So we want to put it into the form y prime plus, write it like this, py equals q. Our integrating factor is going to be e to the integrate p and when I integrate that I'm going to get 3 ln. So let's do this. And in order so that I can cancel out the e and the ln, I'm going to bring that 3 inside as an exponent. So that's going to be e to the ln bracket cubed. So that's going to be equal to bracket cubed. That's my integrating factor. I'm going to multiply 10 plus t cubed all the way through all 3 sides of this differential equation. So that's going to give me this. So 1 here, 1 here, 1 here. Now we're going to integrate both sides. I know that the left-hand side is going to integrate to be y times the integrating factor. The other side, that's going to be, I got to add 1 to the exponent, so that becomes a 4. Divide by the 4, so that's a 2. And this is the stage where we plug in our plus c. How do we get the c? Initial conditions. So initially there's 5 grams of salt. So when I put t equal to 0, y is equal to 5. So 5, when I make t equal to 0, that's 1,000 equals 2. When I make t equal to 0, that's 10,000, so 20,000. Plus c. So c's got to be minus 15,000. Now there's the implicit solution. We could solve for the explicit solution by dividing everything out by that 10 plus t bracket cubed. So we would get y is equal to 2 times 10 plus t minus 15,000 divided by the 10 plus t cubed. And if you wanted to be really super good, you'd make some kind of note here that after 20, that's only good for 20 minutes. But we'll say that that's good enough for full grades there. Now, next question. We want to solve for the explicit solution. So that means I want to solve this for y equals. And they give me an initial condition. Let's take a look at what kind of equation it is. Oh, y prime, it's first order. That's first order linear. But it's not yet in the y prime plus py equals q because of this 2 in front. So I'm going to divide everything by 2 first. So it will be y prime plus py equals q. Integrating factor. The integrating factor is e to the integrate p. So p is 2 cos. Put that up top here. And when we integrate 2 cos, I get 2 sine. So it's e to the 2 sine x. So that's my integrating factor. I should multiply all 3 pieces in that first order linear by that factor. Now, oh, that's nice. E to the minus 2, you add exponents, common basis. E to the minus 2 sine and plus 2 sine, that cancels out. That becomes e to the 0. And e to the 0 is 1. Now I'm set to integrate both sides. I know that the left-hand side is just y times the integrating factor. The right-hand side is going to be 3x plus a constant. They want me to have the implicit solution, so that's going to be y equals and now let's get the constant. When I make x equal to 0, I get y is equal to 2. Sine of 0 is 0. E to the 0 is 1. So c is equal to. So there's my answer. Notice it was important to put the plus c on exactly when we integrated both sides. If I solve, and then tacked it on the end, the plus c would be floating out here, not divided by the e to the trig piece. Next question. Oh, separable. It can written it as a bunch of x's times a bunch of y's. So this y prime, since I'm going to do separation, I'm thinking of that as dy over dx. So let's put our y's on the y side. 1 over cos squared. dy equals n 4x plus 7 dx. Now I'm set to integrate both sides. Okay, integrating the right-hand side, 2x squared, I'm integrating that with respect to x, plus 7x plus a constant. What about integrating this 1 over cos squared? Well, 1 over cos squared is sec squared. And integrating sec squared, that integrates to be tan. Okay, let me stop here. Implicit, so I don't want to solve for y. They don't give me an initial condition, so I'm done. I can't find the c. Next one, number 4, also asks for an implicit solution. And if I look at this, that y over x, this one is sort of screaming trihomogeneous. So, okay, I'll try. Y is equal to vx and y prime is equal to v plus x v prime. And when I make that substitution, I know it's going to be separable. So let's make that substitution. In for y prime, I'm plugging this. I differentiated my substitution. That's going to be everywhere there's a y, I'm putting a vx. So this is going to turn into a v, and this is going to turn into a v. Now, before I do anything, I know it's going to be separable. Oh, and this one's nice. The v's cancel off each side. And since I'm going to do separable, this v prime, let's write that as dv dx. So now I can put all the v's on the v side. and all the x's, there's just 1 over x there, on the x side, and now I'm good to integrate both sides. Integrating e to the v with respect to v is e to the v. Integrating 1 over x, that's going to be ln absolute value of x. I'm going to put the constant in now. Almost done. It says implicit, so I don't want to solve for y, but I can't leave this as just v. I have to make that, I have to switch back. So make the v, everywhere there's a v, put a y over x, and now I'm done. No initial condition, so I can't figure out what the c is, and no initial condition, so I can't figure out if the ln absolute value is ln of just round brackets or ln of round brackets with a minus sign. Number 5. Oh, this one's written like it's exact, but part of the question is we got to show it's exact before we know it's an exact equation. So I'm going to take this first bracket and I'm going to differentiate it with respect to y, because it's already been differentiated with respect to x. So here I got to do, product rule here, because y is, so derivative of the y is 1. Leave the e, leave the second alone. Plus, now I'm leaving the y alone and differentiating e to the xy. X is a constant. So the x comes down, e to the xy. Oh, and the derivative of 1 over x with respect to y is 0. Now, if you differentiate this bracket, the second bracket, with respect to x, you're going to get the exact same thing. Then you're going to get to say it's exact. And if you want to be super good, you can like yell Clause's theorem. So now I know it's exact. My plan is going to be integrate the first bracket with respect to x. So integrating with respect to x, I'm going to have e to the xy plus ln of absolute value of x plus a constant, but in this case, that constant has y's in it. So this is almost done. I just need to know what the h is. Differentiate this with respect to y. So I get x e to the xy plus the derivative of ln x with respect to y is 0 plus h prime, and I set that equal to the second bracket. That tells me that h prime has got to be 2. So that means that h is equal to 2y. So right up here at this stage, I had the answer, k is equal to, but I didn't know what the h was. Now I know it's 2y. Last thing, they give me an initial condition so I can find this constant. When I put minus e in, ln of absolute value of minus e is ln of e, that's 1. And I make y equal to 0. When you make y equal to 0, you get k is equal to e to the 0 is 1 plus ln of e is 1 plus 0, so k is equal to 2. Okay, but now I know what these absolute value bars are doing, so I can't leave them like that. They're multiplying by minus 1, so this is the full and complete answer. If I left those absolute value bars in there, that leaves a whole other fictitious branch of the solution that's not supposed to exist. Okay. Euler's method with a step size of 0.5. How far off the true value? Well, let's get so what I want you to do is go through Euler's method, see what Euler's method says that y of 2 is, and then see how different it is from the true value. Let's get the true value. Well, that equation, y prime plus 2y equals x, it's first order linear. It's a y prime plus py equals q. So we need to just multiply through by the integrating factor, e to the integrate p. P in this case is 2, so the integrating factor is e to the 2x. I'm going to multiply 2x through all three sides. And now integrate both sides. The left-hand side always integrates to be y times the integrating factor. The right-hand side, okay, I don't know what this is off the top of my head. I'm going to have to do integration by parts to figure that one out. So I'm going to do integration by parts here and then plug on a plus c. And I'm going to be able to get the c because y naught is equal to 0. So I'm going to do integration by parts. So I skipped that because you know how to do integration by parts. Let's get the c. When I make y equal to 0, so that's going to be 0 equals 0 minus a quarter times 1 plus c. So that means that c's got to be a quarter. Let's solve for the explicit. So y is equal to, I'm going to divide everything by e to the 2x. That's going to get rid of it here. That's going to get rid of it here. And put it here, but with a minus. Now, we want to know what the true value is. That's when I make x equal to 2. So that's going to be a half times 2, that's 1. E to the minus 4. So let's work this out as a number. Just do it on a calculator. I get 0.75 and change. Now let's do Euler's method. So for Euler's method, new y is equal to old y plus hy prime. So new y is equal to old y plus h. Y prime is this formula, this x minus 2y. Oh, and the h is a half. So I plug in a point and I get out the new y. So I'm at the point 0, 0. So then the new y is going to be 0. The new x, I move over a step size of a half. So if the first point, the point they give me, is 0, 0, the next point, the next x point would be 0.5, and the next y, the new y, would be 0. So that's one iteration of Euler's method. Now now I know that Euler is saying that y of 0.5 is equal to 0, its estimate. We just have to chug through. I need one. So now I'm at the point where y is equal to 0 and x is equal to 0.5. So plug this in. That's going to be 0 plus a half minus 0, a half times a half, a quarter. So this is going to be 0.25. And now I need to plug this point in. (1.5) is the x value. When I plug in the 1 and the 0.25, I get, plug this in to get the next And I think I get, well, let's do it. 0.25, that's going to be a half. 1 minus a half is 3/4. 1 plus a half of 3/4 is 1 plus 1, that's 1.5. So here it filled it in with the chart then. Then I'm at the point 1.5, 0.5, plug this in again to get the new y of 0.75. All right. The true answer from the solving is 0.75458. The Euler's method says 0.75, so how far am I off? 0.00458, or that value. Last question, sketch the null clines. The null clines are where the slope is equal to 0. So I'm setting the y prime equal to 0. There's two of them. Y equals 2 is one of them, and y equals x squared is another one. So I need to draw those two null clines, same slope. So let's sketch the that's one null cline, right? On the curve when y is equal to x squared, the slope would be 0, and I just got to draw the y equals 2 line in there too. So that line, the parabola and the line, there are the null clines. How does that sit with you?